Hi, this is Paolo, and today I'm going to show you an interesting tutorial on how to fix UV maps in poser hair when they go wrong. Now, there are two possible solutions for this problem. One is simple, but it's a hack, and the other one is a real fix. So I don't want to make things too easy, so I'll go and show you the real fix today. So let's take a look at the example of the problem. Here we have an example of a hair straight out of the installation, and this is rendered in DAZ Studio. Now we can see here at the base of the strands these weird polygon shaped artifacts, and you might wonder what the hell is that? Well, I'll show you in a moment. Let's take a look at the hair as it appears normally in DAZ Studio. So those artifacts seem to be appearing from nowhere. Now if we load the transparency map for this model, now we can see the strands, and a transparency map, in case you haven't played with that before, is simply a bitmap, a JPEG file, like in this case, where black means the area is transparent and white means that the area is actually painted. This map particularly is 512 pixels by 512. It's a very rough map. Normally today's textures are around 2048 pixels per side. So this is a low quality map. But what is causing the problem? Now, to understand how this works, you have to understand how textures are painted on the model. So let's go back to DAZ Studio for a second. Okay, here we have our model back, and here is a view of the UV map. The UV map controls how the textures are actually painted on the model. Now in the UV map you can see an outline right here, and this is the scalp, basically the top of the hair. The end of the strands, these portions here, let me rotate the model a bit. Here, this outline that we see, those are basically mapped on these rectangles that we see. Basically a UV map, it's like the proverbial orange peel. You take an orange, you peel it, and then you take the orange peel and you make it flat. And that's where we paint the textures. Now the transparency map we just saw is basically telling Studio or Poser or Carrara where pixels need to be made transparent. Now what's happening in this specific case, let's take a look at the render again. So when we look at the area here, these are exactly the shapes of the polygons that create the shape for the hair. Now this tutorial was actually inspired by a post in the DAZ Studio forum, and let me show you the artifact that the original poster actually showed to us, and the reason why she asked for help, because it was very hard to figure out exactly what was going on. This problem here is analogous to what she showed to us in the forum. So how we fix it and what is causing it? The cause is actually rather simple. If we look back at the UV map, what's happening is that the map, it's very hard to see, but it's actually extending probably just 1 pixel beyond the 512 pixels allowed. Each UV map has a predefined size. Usually it's 1024 or 2048. If the UV map extends past that grid, then the pixels, actually then the vertices will be painted in the wrong way. So let me show you more in detail how this works. And for this, we will use Blender. Now, Blender is a 3D modeling software. It's free, it's open source. It's available for Macintosh, for Windows, and for Linux. And you can download it from blender.org. So you can follow this tutorial and fix your texture problems without buying a new software. So let's switch to Blender and let's load the hair we just used. Now that is an OBJ file. And so we go to File, Import, Wavefront OBJ, navigate to the directory where the hair is, and normally if we look back, there will be in your runtime, geometries, and then the name of the product. I keep each product installed on a different directory to make things simpler. Otherwise you would end up with, possibly thousands of files together in a single runtime directory. So this is the reason why you see just one product. If you look back, I basically have everything under a directory called DAZ content, and then I have a separate subdirectory for hair, and I installed this LQ RevBob hair, runtime, geometries, name of the product, and then I click on the OBJ file. When I click once, the name of the file is copied here in the file input field. Then I click on the import a wavefront OBJ file. And for this, we will just need to keep the settings in this way. We don't need this flag, we don't need this flag, we don't need the polygroups, and we will not need the image search. Now, we will not, I repeat, we will not change the original OBJ, so you can relax right now. We will create a new OBJ with a new UV map, and so the original installation will not be affected in any way. And then we click on import. Blender thinks about this a little bit, and then the hair seems to be nowhere to be found. It's actually a pretty small prop, so let's rotate it a little bit. Right click to select it, press tab to go in edit mode, and then I'll click this button to just show the faces, not the vertices, and then this other button to occlude the background geometry, which will just show the geometry is visible from our viewpoint. Okay, let's move a little closer, and I'll press A to deselect all the polygons. Okay, it's a little easier on the eye. Now, if we rotate a little bit, we see those outlines that were visible during the render, and this is exactly what is causing the artifact, or more precisely, the incorrect UV map exposes those shapes. So let me just change my background here, my desktop here. You will not have this arrangement because if you're new to Blender, you will have the standard Blender desktop, and there are excellent tutorials on the web on how to arrange it. So I will not give you a tutorial about the Blender user interface. Then you will need basically a split panel here, and select the UV image editor. Now if I press A, the entire model will be selected and the UV map will be shown. So let's come a little closer, and let's highlight a ring of these polygons here at the end of the strand. Let's call it a strand. So to do that, we just right click while pressing the Alt key like this, And here we see the UV map corresponding to that loop of polygons. Now let's deselect it for now. Press A and click on this other strand. Again, press Alt and right click. It's exactly the same area. In fact, if we keep repeating the same exercise, we see the same number of polygons here highlighted in the UV map. And how is that possible? Well, in Poser, multiple UV maps are overlapped in the single map, and the program knows exactly how to work with those. You cannot quite see it, but these are perfectly stacked on top of each other. In fact, if I press Shift Alt right click and highlight all these, we apparently don't see much changing here. So let's take a look what really happened. Let's get a little closer. Now I'm right clicking on one of the vertices here and press G for grab, which means in Poser we are moving, we have the power to move objects in the view. Now press G and move the mouse. Now you see I can move this vertex, but right there is another vertex underneath that one. So they are perfectly stacked on top of each other. Press ESC to cancel the operation. So basically every single end of the strand is mapped in this area. And what happens is that the very end of that, this line here, is the edge, is the final edge here. And these vertices in the UV map are just 1 pixel beyond the real area. When they are past the limit of the UV map, basically the program makes them go and wrap around back at the top. But now if we look at the transparency map, at the top that is all white, and white means color, and that is the reason why we actually see the shape of the edge, because this area here, the white, says to Poser or DAZ Studio, paint that edge. Now here comes the easy solution. You could just go in Photoshop and paint 1 or 2 or 3 pixels in this area black, and it will fix it. But that's kind of a hack. Okay, it doesn't really fix the UV map, it just creates a workaround. Now we're gonna really fix this map. Very easy. Now that we know exactly what part of the map handles the edge for all the strands, let's press A with the mouse here in this view. Let's press A to deselect everything and press A again to select the entire model. Okay? Now let's move the mouse in the UV map. Be sure that you're deselecting everything. Again, press A couple of times just to be sure. Okay? And now press B for the rectangular selection. So press B, the crosshair appears here. Now click, drag, and extend your selection all the way to here. Be sure that you're not highlighting any of the pixels here. If you're in doubt, press A again to deselect. Get a little closer if you need. Okay. And press B. Stay as close as possible to the edge. Extend the selection. Done. Now what we're going to do is to simply move this edge, which contains a number of vertices on top of each other. We're going to move this edge just a little bit inward, and that will fix the map. Now to be sure that this works correctly, let's go to the menu here in the UV and say snap to pixels. This will make sure that those vertices, when they are moved, will snap to the exact pixel coordinates. It's another warranty to make things work correctly. And just to have an extra safety net, let's select Layout Clip to Image Size. This is what the original designer of this map should have done. This option here guarantees that wherever we move the pixels, they will stay inside the confines of the map. Okay, so now the setup is done. Let's press G for grab and press Y to confine the movement inside the Y-axis. What it means is that it will only go up and down vertically. It will not allow any side movement. Okay, and so let's just go just a tiny bit up and click, and that's all. That's how we fix the map. Now let's save this and see how we can use it in DAZ Studio. So press Tab while in this view to exit edit mode. Go to File, Export. We want to export this model using the OBJ file format, and we will use a different name so we don't alter the original geometry. So export wavefront OBJ, and depending on your layout, the file box will appear somewhere. In this case, it's happening here. No problem. Let's go back to the exact same directory where we loaded the original OBJ file from, and here we see it's called revbob.obj. Let me just append an _2, not very original but perfectly legal, and click on Export. The options we want are standard like this, minus the edges, minus the materials, minus the polygroups, minus the nerves, and just click Export. That's all there is about this phase. Now let's see if this works inside DAZ Studio. So let's switch back to DAZ Studio, and I'll switch back to one single view, texture shaded. So this is our hair. In order to use the new UV map, and see, even in this view we can see the artifacts. We go to the Surfaces tab, we select the hair group, okay, and here in the menu we take advantage of this new feature. I think this is actually new in DAZ Studio 3, Load UV Set. This allows us to change the UV map for this model. So let's click on this and select our newly saved OBJ file, and then DAZ Studio will ask us for a name to identify this set, and we call it UV corrected. Okay, now a little bit of thinking. Now below here, at the end of the shader panel, we see the UV maps option. Click on the button and select the newly created UV map. Now Studio will think about it for a second, apply the new UV map, and you see the artifacts are gone. Let's do a quick render. I'll do a region confined render just to verify that this works. And here it is, it works. So without changing the bitmaps, without changing the textures, we are now able to apply on the fly a new UV set. And that shows exactly what was wrong and how to fix it, and how to fix it without even having to change the original OBJ thanks to the new feature in DAZ Studio 3 that allows us to load the new UV set. I hope this was useful. I'll see you next time.